everyone. How are you? Thanks for joining us. I'm Nicolas Gonzalez. I'm a solution architect in Ingenia, and also joining me is my teammate Federico Catinello, also from Ingenia. We are at Ingenia. We have different clients from big banks to fintech to small startups, something from healthcare, from different topics, but all of them have something in common. What they do have in common is that they have a product in production that doesn't not accept any downtime, and they need to get adapted really fast because everything changes. And whenever they need to do that, they have like different approaches, but it needs to change fast. It needs to change easily, and the user doesn't need to realize that something has changed. So, what are the businesses for this? First of all, they do need to release experimental features to users and see if it increases the sales, because someone tries to say, okay, let's try out a new dashboard, let's try out something new and see if that's increasing the sales or not. Or maybe what they are doing is just changing the infrastructure behind it and trying not the users to see that something changed. So the user shouldn't have something that changed, but the infrastructure should be better. Maybe they are just releasing a new feature for beta testing, or maybe they are just releasing a new feature for a small set of users. So what comes there, it's what Canary deployments comes in. That's where Canary deployments comes in. And as you can see in this picture, what Canary deployment is a pattern for just rolling out releases to a subset of users or servers and let them be the ones that are trying out the new version. So as you can see here, there are a lot of users, but those users can be either in treatment A or in treatment B. Whenever they go to treatment A, as in the 90%, they are just gonna be serving the real application, the application that's been working, and we know it works and everything works okay. But whenever they go to treatment B, that's where we are trying to try out new features, so maybe we change something. And whenever that happens, it might break. But it might break only for those two users over there, not all the users. And we can realize very easily, fast, and iterate on that for the rest of the users to keep using their real application. So as you can see in the next one, how users are gonna participate in this can be something like randomly, as we said before, like for instance, 10% to 90%. Maybe you can just roll out for a region. Maybe you can just create an early adopter program or do what it's called dog fooding, which is, okay, we are the ones that are gonna try out our own product and see if everything works okay. If it works good for us, it should work okay for the rest of the people. So coming up next are what are the benefits of this? First of all, as you can see in the next slide, is A/B testing. You can do Canary deployments to do A/B testing. Let's try out these two versions and see which ones performs best. The next benefits of this is just for capacity testing. Maybe you're rolling out something that might change a lot and might change the times. So when you do Canary, you can stress out a small part of it and see if it works as expected or not. The next one is feedback, because whenever you roll out something new, you expect feedback from the real user, not just a UAT user or a testing user. You want the real people to give you feedback, and you can roll it out right away. Then we have no cold starts, because you are just running two versions of it. Whenever you are confident on the new one, you just go to the new one and start using that one. You don't have to stop everything and roll everything up. You just keep working with that one. We have two more. No downtime, as I just said. And the last one is just to easy rollback, because you have two versions. Whenever this one doesn't work, you can roll back and go back to the old version and keep working as it should. As I said in the image, there were a few users who were just in the wrong version and it broke. You can just discard that version and go back to the old version of that. So coming up next is where is Canary is not. Canary deployment is not something for green-blue deployments. It's the idea behind this is not to just create the two applications and start rolling up from this deployment to this deployment. That's something that's meant to be for a load balancer or something like that, that just creates two instances and moves from one to the other. It's also not a rolling deployment. You don't want to just, okay, let's start destroying the instances who are on the old version and moving to the new one. What you are doing with Canary is you have two versions and you're trying out things in the two ones. So that's just the theory. So let's just jump into our showtime. Yeah. So what we have here is we have a real life example. Foodex is a mobile ordering solution that allows you to just download the application or enter your web app, create an order for a restaurant, pay through the application or the web application, go straight to the barman, and after that, you can retrieve it and then show it with your friends. The idea behind this is that you don't spend much time ordering, but you spend a lot of time with your friends. So what happened here is that Foodex, to provide all these things, the first things that you have to do is to access easily, very easily, your places. So as you can see in the two images here, you have different places in places nearby. And also when you provide an address, you can get the places nearby that address. And as Fred is gonna show in the next few slides and in the demo, uh, that's something that was having trouble with one version. We created a whole new version for it, but there was such an internal change that we needed to try out not only in testing, but also with real case scenarios of what was gonna happen. And that's what Canary comes in. So Feder,
Okay,
that's take it up from here and please show us the demo.
thanks, Nico. Okay, based on what Nico just mentioned, here we have an architectural diagram of covering all the Fudex business needs. Here we see it's pretty straightforward. We have a backend with the managed Kubernetes on a cloud provider. In this case, it's Google. And then we have two kinds of application. One is web-based, and the other is a mobile version. And that are consuming services through a Kong Ingress controller. Kong Ingress controller is the one responsible for exposing that functionalities to the outside world. And then we have, which is called BFF. BFF is a pattern. The letters are backend for frontend. It's a pattern which allows you to have a detailed experience for each of the frontends you have on your architecture. And then we have the backends. The backends are also built in Python as the BFF. BFF uses the Flask network framework, sorry. And the backend is built upon Django. Okay, it's storing the main data onto an SQL database, a relational database that it's as a service. All this architecture is being observed by Grafana. So we're going to see live metrics at Grafana, what's going on with these components, right? Then we have the problem with the first backend, as Nico mentioned. It was really slow. It was really slow because all the processing before saving the data was being done on the backend side. So that's brings a lot of issues. So now we are going to set up a new whole version, which is called backend B2. It's going to be the same stack, the same technology stack, but it's doing the processing near the database layer using Postgres on the PostgreSQL. So for accomplish this shifting of the traffic to send over 90% to one version and 10% to the other version, we are going to use Kuma. What is Kuma? I think you all should know about Kuma. Kuma is the Kong service mesh solution. As any other service mesh technologies, Kuma has the concept of a control plane, which is responsible for not only managing the data planes, but also configuring them and observing what's going on at every time. It's like the brain on our service mesh. And then we have the data planes, and we can see here on the image at the bottom, the data planes are the Envoy proxies that are being deployed as sidecar containers of our application containers. So given this configuration, given this scenario, service mesh implementation allow us to observe all the traffic that is incoming and the outgoing traffic for our applications. And therefore, we can configure some security policies, routing policies. We can do some Canary, as in this demonstration. We can do also blue-green deployments, and we can observe all the applications. I mean, we can grab all the telemetry, I mean, logs, metrics, traces, and centralize them in another backend storage. What happens if we don't have a service mesh to do this, to accomplish this need we have? Well, in that case, we are gonna need to set up some business logic inside the application in order to know, okay, the traffic has been sent to me, so it's not my turn to respond, so I have to derive the traffic to the other box. And that's not the ideal scenario because it doesn't scale. When I had to implement a lot of particular rules there, it's not the best way to, it's not the best approach to accomplish that. So given this scenario, we're going to show now the demo. Here we have in our cluster, we have, okay, let me check. We have the applications. In this namespace, we have the BFF. As we told you, we have the two versions of the backend. Of course, the second version of the backend is not receiving traffic at all at first because no traffic is sent there. We didn't configure anything yet on the mesh side, on the mesh layer, so all the traffic is going to the B1 version. Providing that, we also have the ingress here, the ingress controller. And now we are ready to show you how the application looks like. The main idea of all this demonstration is to show you us like it is a seamless transition to the end users. The end users are never gonna realize the changes on the application side. Here we can see that if I reload the application, okay, there is traffic that is lasting too long. Here we have it. It's like 6 seconds to bring all the data we can see here. So this is the main reason, the main trigger that we use to set up to spin up the new version. Given that case, we are now going to show you how in Kuma we can configure that traffic routing. It's a YAML. It's like a Kubernetes object, but from the Kuma API. So it is called traffic route. What it says here, it says, okay, all the traffic that is coming from this component observed by Kuma Service Mesh, and it's going to this destination component, send all the traffic to the first version. We have here the Kubernetes label that it's specifically saying that it's version 1. Send all the traffic. It's a weight-based probabilistic traffic shifting to the first version and 0 to the other version. So what happens if we change this? I'm going to run a script here to call the API. And we can see now in Grafana, we can see now in a matter of seconds that we have traffic. We are seeing two dashboards here. We configure a dashboard with the total request on a rate of 30 seconds. And then we configure the request time per service on a BFF viewpoint. I mean, if I look at the BFF and I ping the BFF every couple of seconds, I'm gonna see, okay, it's lasting like 9 seconds to bring all the data together to the view, right? So this is based on percentiles, but the worst percentile, the P99, is showing that it's taking almost 10 seconds to accomplish that request. So now we're going to configure traffic route to send part of the traffic, let's say 70, again 30, to the second version. We did a CI there in order to changes. And then we can push the changes to our GitLab. And here we have in GitLab, we have like the pipeline, which is doing all the magic there. It's running right now. So what this pipeline is doing is applying that file with kubectl command to the cluster. It's take a couple of seconds. And now we are gonna see, if we move to Grafana, we are gonna see that part of the traffic is going to be shown with the red, sorry, the yellow line that is tracking the V2 request. Let's wait a couple of minutes, seconds.
So Fede, what you just did there was you just changed the rule to say, okay, start sending something to the old version and something to the new version. Almost all of our users right now are going to be going to the old version, but 30% of them or something like that, because it's not just a 30%, but it's a probabilistic. It's going to be sent to the new application, right?
Yeah, that's right. So we see here that the yellow line is starting to show some rates here based on the IP request, and also the traffic it's been decreased. Or at
Yeah, the
least we are
times
going to
are
see it.
better.
Yeah, that's why, because we moved to the new version, as Nico just told us, that has the processing, that massive processing layer being done in another layer, which is the best approach to do that. So in that case, we see that the times are getting better. And we see that here there are requests coming from both versions. So imagine the time goes by and then you are ready to put 100% version traffic, sorry, to the new version. Well, in that case, what you're gonna do is the same, but putting all the traffic to the second one. Sorry, here we have 0. We're going to apply again the changes. V2 to 100%. Push the changes again. And then we should see I will have a new pipeline here. I will implement that file. Okay, in a matter of seconds, it will finish. And then we will see that the green line is going back to 0. And the yellow line is going to be the one receiving most of the rates every 30 seconds. And the
Great. So
times should improve in a matter of time.
So none of the users realized anything apart from having a performance improvement, but the data is still the same. Everything is still the same. The only thing that changed is that everything works faster right now, right?
Yeah.
And if something was not working right, you could just roll back and go to the previous version because it's still there. It's still being processed in the backend, and if something comes up, you can just roll it out back.
Look, it decreased to 3.8 seconds, half the time the other version. Okay, that delay of 3 seconds is because it's going to another region, the database, to grab the data, sorry. And we have a latency between regions. That's gonna be acceptable for the demo, not for production, of course. And then we should see here that, okay, the time decreased considerably and the yellow line started to receive all the traffic. I mean, all the rates of the request are going to the V2. So now we are good to go with the Canary, and now we are good to go with the new version for the users. The version is tested and it's ready to be used.
Awesome, great. Great, thank you, Fede. That's really cool. So Fede just show us how Canary works, and Canary almost every time works, but we have a few things that you have to keep in mind. Let's find them. So the first thing is do not over rely on this because it does not effectively mitigate the risk of silent defects. What this means is, for instance, if Fede just introduced a new defect into the version 2, you will be trying that one in production. So don't over rely on this, and also try it out in testing, try it out everywhere, because you are pushing code to the production, right? This is only possible where there are no contract changes, because if something changed and the UI would need to change its response, this couldn't be as easy as it was, because you cannot change from one to the other one, right? It also increases the complexity, because as Fede just showed us, he was just pushing something to the automated deployment mechanism and it was being deployed. But you have to keep in mind that apart from the routes, ingresses, and everything else, you have something else that's the route between the services, and you have to keep that in mind too. If not, something's moving and you don't know why. Apart from that, and it's really important, as Fede just showed us, you have to be having a look at what's being changed. You have to be measuring the changes. You have to have a lot of metrics on this. If not, it's just something that's being changed and you don't have the ability to see if everything is working okay, if it's not, if it makes sense. One of these is one of the most important one, that database changes can present a problem. For instance, if you have a version that's faulty, then the database would have changes that are not that might be corrupt, and that's data that's corrupt. Even for the latest version, the previous version, every single version is looking at the same database, and if everything works not the way as expected, the database is being corrupted. And the last one, but not least, is make sure you're routing the traffic to the mesh, not to the load balancer. What this means is you are just sending all the information to Kuma in this case. So if Kuma is the one that's taking care of this, it will be able to just use the Canary. If not, if it's just going straight to the service, you are going through Kuma and none of this will work. One last thing that's also important is that you have to have stages. You have to keep in mind the duration of this. You have to keep metrics for this, as we said before, and you have to keep an evaluation of this. What this means is you have to plan. You don't have to just, okay, let's go with just spinning up things and going to Canary deployment and everything will work right. It might not. It might, and you have to have a lot of observability on this, to have metrics on this, and to decide whether this Canary deployment makes sense for the end users or not. And if the answer is not, you have to quickly roll back to the old version and keep everything working as normal, right? So as you have seen, we have seen a little of the theory. We have a little demo with a real case scenario. You can check it out in the links that you have there, that this is something that happened to us. This is something that we implemented. We would like to thank you all for joining us. Thank you, Fede, also for the whole demo. We would like you to stay tuned with us to keep up with the questions right after this session. So thank you all for coming. Hope you all enjoyed it as much as we did creating this one.